Hello everyone. In this lesson we will take a look in how you can add images to your game, how you can edit them. For example, if you want to scale an image to become smaller or bigger, there is a way to do this from Pygame. And generally we will be taking a look at how you can manipulate images with PyCharm or with Python in general. So the first thing you need to do is go ahead and download three images. So for example, I'm using this jet here, this cloud.png and this bullet.png, and I'm going to first of all load them into Pygame, then scale them if I need to, and then paste them onto the screen just like we did with text last time. So first of all, we can go ahead and add them over here. So jet equals to pygame.image.load, and in here we specify the name of the image. So be careful, your images must be at the same directory, at the same folder as your .py file. If it's in a different directory, you would need to specify the path as well. So it's easier if you just put them all in the same directory here. So I'm just going to say jet.png here. So then let's scale up the image, or actually scale it down in this case. So we're going to say jet equals to pygame.transform.scale. So this just changes the scale of the image, jet, and then we specify the size that we want it to be. So 150. So 100 by 50 pixels will be our final image. So just one thing to note, it's better if you don't use this method actually and just scale it on an image manipulating software. This way it will be of a better quality, but just as a showcase here, you can use this method as well. So finally, what you have to do is, let's create a jet rect, which will be equal to jet.get and rect. So this will get the rectangle object of the image. Oh, I forgot the equal sign here. So next what you have to do is do game surface dot blit. So actually paste it onto the screen or the game surface and jet comma jet rect. So if you actually go ahead and run this. Oh, and actually all of this code needs to be inside of our game loop here. And also let's make the fill white this time. So it looks kind of like a white background. So let's run this. And as you can see, we pasted the jet on the top left of the screen. So just the default location. And as you can see, it's resized. So if I just remove this line over here that scales it, it's going to be way too big to even be able to fit the screen. So, but as you can see, the quality of the image has gone down a lot. So it's better if you scale it in another program beforehand. And actually, if you want to be more correct, you could just take all of this out and jet rect as well, and just paste it outside of the game loop. And the only thing you're doing inside here is you're just making this, you're pasting this on the screen. You're actually setting what the jet is outside of your loop, and then inside your loop you're pasting it on the screen. So now what I want to do is I'm going to add another color here, so light blue, and the values for light blue are 135, 206 and 250. These are roughly light blue values. So next let's go ahead and define the other images as well. So let's go ahead and define cloud. Let this be equal to pygame.image.load, and this should be cloud.png. And let's go ahead and also define the bullet, which will be equal to pygame.image.load. As you can see, PyCharm already finds the bullet.png inside our folder and lets us autocomplete this. So it's even more easy to do it this way. Now let's go ahead and scale every other image. So this should be a cloud equals to pygame dot transform dot scale, and this could be just cloud, and let's just give it the same here for the width and height. And also let's go for bullet. Actually, bullet might be already the correct size, we will see later. So then what we have to do here is let's get rectangles for all of them. So cloud rect equals cloud dot get rect, and also bullet rect will be equal to bullet dot get rect. So another thing we could do here is we could also set our cloud rect dot top right, and let's set this equal to display width and 0. So just set different locations for the images so they're not on top of each other. And let's also do bullet rect actually dot top right, and let's set this equal to display width and 100. So next, what we have to do here inside of our game loop is make this here light blue and just paste the rest of them here. So just copy this and change this to cloud and cloud rect, and make this a bullet and a bullet rect. So if we run this, you can see that we have already pasted all of those things here. So the bullet actually kind of has a white background, so it looks like this, but just for demonstration purposes, we don't really care about that right now. So let's go ahead and review our code alongside with our window here. So we are setting our images, we're loading our images here, and then what we are doing over here is we're scaling those two images, the jet and the cloud. Afterwards, we are getting the rectangles for all three objects here, and then we are setting the top right of the cloud and the bullet to be this corner here for the cloud and this corner here for the bullet. So when we display them, they're going to be at these particular positions. So inside of our game loop, we are just pasting them onto our screen. The process is very similar to what we did with the text the previous time. The only difference is you actually have to load and scale the image. But other than that, it's pretty similar to what we did before. So now let's actually create what is called a user event. So Pygame has all of these events like pygame.quit and all of the other events that we particularly showed when we did the keyboard detection and the mouse detection. But we can also create our own events. They're called user events. So let's go ahead and define one user event over here. So let's call this one make cloud and set this equal to pygame.user event +1, and this will all make sense in a little bit. And let's also do pygame.time.set timer, and let's put inside here the name of our user event and 1000 here. And let's also create a list called cloud list. This one is going to have the coordinates of our cloud's position. So we're going to create sort of like an animation for the cloud. Okay. So then we have 200,30. And finally we have 300,60. Let's just space it out more evenly. Okay. So these are the coordinates of the cloud that it's going to take to make it look like it's an animation. And let's also go inside of our game loop, and inside here we could just say elif event.type equals to make cloud. So this is our own event, and we also have to import random here to make it look more random. So import random. Okay, so now in here what we want to do is just say x equals random.rand int, and let's do between display width and display width plus 50. So this is going to pick a random number for x between the display width and the display width plus 50. And then we have the y, which will be equal to random.rand int between 0 and 300. So then we will append those coordinates to our list. So we will do cloud list.append, and now we will just add those coordinates to our list. So next we want to loop through the cloud list coordinates and just paste the cloud onto our screen every time we do that. So let's go under our event handler, and just after pasting the and filling the game surface, we could do for coordinate in cloud list. So this is going to run for every coordinate in the cloud list. We could say coordinate 0 minus equals 2. So we're just making the x value smaller every time this runs. So we make it look like it's moving. And then we're doing cloud rect dot top left equals coordinate. And just afterwards we have to do game surface dot blit to actually paste it on our screen. And this is going to be cloud and cloud rect. Okay. And now let's just clean up the cloud list by removing our unneeded coordinates. So let's go ahead and make another for loop over here. So for coordinate in cloud list again. Now what we're doing is cloud rect dot top left will be equal to our coordinate, and then we're going to check if our cloud rect dot right is less than 0. So if we actually touch the edge with our right side, so if our cloud actually disappears from the screen, what we want to do here is cloud list dot remove, and here we specify the coordinate. So I think we're done here. Let's just review this before actually running. So here we're making our new event, and because Pygame stores events like integers, we're adding 1 to it to make sure that this is actually a unique event. And we're using all caps here because this is the convention for all the Pygame events. So afterwards we're doing pygame.time.setTimer and make cloud, which is our event, and 1000. So here we're using the time module setTimer method to add our custom event to the event queue, which will fire every 1000 milliseconds. So this number here is in milliseconds, and 1000 milliseconds is 1 second. So this event will be triggered every 1 second. So the user doesn't have to actually trigger this, or we don't have to actually put this inside the loop or anything like that. This just makes it run automatically every 1 second. So then we create our cloud list with the initial coordinates to have something to get started with. And now let's take a look at our custom event here. So this is our custom event. So we're setting x to a random number between display width and display width plus 50. So what this does is it makes the clouds start from right after the edge of the screen, so they don't just pop up, they just start moving from the right all the way inside the screen. And then we're actually choosing a y value that will be random between 0 and 300. After we have done all of the choosing random integers for our coordinates, we're actually passing those values and appending them inside of our list. So afterwards, let's take a look at our for loops. So first of all, we are running this for every coordinate in our list, and we are setting this is the x value, because this is a list, and x is the 0 value, 0 index, and y is the 1 index. So we're setting 0, which means the x value, to be minus equals 2. So we're decreasing slowly the x value to make this look like it's moving towards the left. And we're also setting the cloud rect dot top left to be equal to our coordinate. So we are setting our location at this coordinate that we just chose here, and we're actually pasting it on the screen. Pretty straightforward. And here we're actually removing our coordinates from the cloud list if and only if they reach the end of the screen. So the right part of the image, the end of the image has actually entirely left the screen. And here we're just pasting everything again over here. So let's go ahead and run our program and see if it actually works. So you can see we're displaying all of the clouds from the left side or the right side of the screen, and the y value is actually random between 0 and 300, and we are slowly decreasing the x value, like right here in this line, so we make them look like they're moving towards the left. So this is a pretty cool animation we have created for our clouds. It's also pretty random, so it feels more natural. It doesn't repeat the same thing with the same numbers. So yeah, that's pretty cool. And one more thing, the reason why we are removing all of these coordinates from our cloud list is because we don't want it to fill up and take much more memory than it needs to. So generally in programming, we try to make our programs as small as possible to take up as less memory as they can, because much larger programs have to be more efficient with memory and with processing speed. For now, this wouldn't make such a difference in our memory, but if we wanted to create a much larger game or a much larger program, we would have to pay attention at things like clearing up memory that we don't actually need. Alright, let's do one more thing. Let's make bullets move towards the plane. This will be a similar process to what we did with the clouds. So let's go ahead and in here just create another custom event. So let's call this make bullet, and let's set this equal to pygame.user event +2. Remember, this stores them like integers, and by doing +2 we're just putting this next to make cloud. The order doesn't really matter, just keep in mind that this is how Pygame stores events or user events specifically. So pygame .time .set timer make bullet 750. So what happens here is this event is triggered every 0.75 seconds. So just like we did before with the cloud timer, we're doing the same here with the timer for the bullet. So let's go ahead and actually create our list here for the bullet. So we can call this bullet list, and let's set this equal here to display width, 20, and display width plus 20, 100. These are just different starting values for the bullets, and display width plus 40, 160. Okay, so we're done with anything outside of our loops. So now inside here, let's go ahead and add this to our event handler. So elif event.type equals to make bullet. So what we want to do right now is x equals to random.randint. This is going to be display width and display width plus 50. So just the same thing that we did for the cloud, we're doing for the bullet. And y will be equal to random.randint, and this will be between 0 and display height. So this could take up any part of the y for our screen. We don't have any restrictions for that. And what we want to do next is bullet list dot append, and now we're just appending x and y onto our list, just the same process that we did for the make cloud event. So let's go ahead and actually program our loops for the bullet. So for coordinate in bullet list, let's set the coordinate 0, so the x value minus equals to 4. So this will just move faster than the cloud did. So this has a minus equals 2, this has a minus equals 2. So basically it's going to be double the speed for the bullet. So then bullet rect dot top left, and this will be equal to our coordinate. So just like we did before, we're setting the coordinates that we picked randomly before. We're just setting them inside here. And finally, let's do game surface dot blit. So let's paste it onto our screen, and let's do bullet comma bullet rect. Okay, now let's make the for loop that cleans the list up. So for coordinate in bullet list, and let's do bullet rect dot top left equals to coordinate, and afterwards let's just check if our bullet rect dot right is less than 0. What we want to do is go to bullet list and remove these actual coordinates. So whenever we see that this here has left the screen, we're just removing this coordinate from the list in order to free up some memory. So let's go ahead and run our program here. And as you can see, this works as expected. It does the same thing as the clouds. The only difference is that we now have no restrictions as to where on the y-axis our bullets are going to spawn. And they also move twice the speed of clouds. So if you can see, they are surpassing the clouds. They are moving twice as fast as them. So as an exercise, and this is quite of a revision exercise, you can make the Z move using the left, right, up and down arrow keys, but make sure that the Z doesn't go past the screen boundaries in any direction. So make sure that the Z does not leave the screen accidentally. So today's lesson was a lot to understand. Make sure you review the code and practice a lot, because without practice you actually will forget whatever you just learned and you won't be able to actually move forward. So really, really important, keep in mind, just revise, just read your code, read the example code, understand what it does, and practice, practice, practice. Thanks a lot for watching.